Horse is a horse, of course, and no one can talk to a horse, of course. This is Mr. Ed. Now, I'm not old enough to actually remember when Mr. Ed was on television, but I am old enough to remember when Nick at Night played sitcoms that weren't made when I was a kid. And so Mr. Ed was one of them. Mr. Ed was a horse who could talk, but he only talked to his owner Wilbur, and so hilarity ensued. But I used Mr. Ed to talk to you a little bit today about the interesting story of a horse called Clever Hans, who's got something to teach us about experimentation in psychology. So let's check it out. It's Germany. It's the year 1900. So we are 20 plus years into psychology's transition into being a science. And so this is going to be one of those opportunities we see where a psychologist is going to really try and use some of the tools of the scientific trade to prove some things about learning. We go to the farm of a fellow named Mr. Von Austin. Mr. Von Austin gains a fair amount of notoriety in his community because he is the owner of a horse named Hans. And this horse, Hans, can supposedly do addition and subtraction. He is what I have called here an equine Einstein. You don't get that kind of thing other places. Just want you to know how hard I work for those bullet points that I give you. People were coming from kind of all over the place to see Clever Hans, wanted to see this amazing thing. But there's a psychologist, a man by the name of Oscar Funkst, who is out to ruin the party. He's a psychologist, and he is pretty sure horses can't do math, and so he goes out to see if he can figure out what the trick is. Not exactly an odd occurrence back in the day for people with less than pure intentions to try and mislead the public, right? This is pretty close to the era of time where you could get some really effective diet pills that were actually eggs for parasites. That tapeworm, right? Yeah, it may take up residence in your small intestine, but you are going to lose weight. Or teeth whiteners that took off your enamel, crazy things like that. And so Funkst goes out, and this is the scene that he sees. Mr. Von Austin would stand in front of Hans, and he would give him math problems one of two ways. Verbally, Hans, what's 2 plus 2? Or show them on a card to Hans, and Hans could do the addition or subtraction either way. Now, Hans didn't tell him the answer. That would have been a cool story. Hans would stomp out the answer with his hoof. And so 2 plus 2 would get 4 stomps. And Hans was right about 90% of the time. I know what you're thinking. That's astounding. There are freshmen that can't even get that many math problems right. And so Von Austin is going to travel out to see this really with Funkst is going to travel out to see Von Austin really with a skeptical eye to what's going on. And so he walks around the scene. He sees this crowd that's gathered around Hans, but he just can't figure out what the trick is. He looks for a lot of different little things, but he's almost like that guy at the magic show that's frustrated that he can't figure out how the magic is happening. And so he hits upon an idea. He goes and he asks Mr. Von Austin if he could give Hans the math problems. And to his surprise, Mr. Von Austin said, sure, that sounds like a great idea. When Funkst would give him the math problems, Hans could still answer at that clip. And so, Von Austin knew he wasn't in, or Funkst knew he wasn't in on it. And so he becomes convinced there's got to be something else. Now, you got one of two choices, right? You either admit you've been beat, or you admit a horse can do math. Funkst isn't wanting to do either one, and so what he does is he hits upon an idea. He's going to give Hans the math problem on the cards, but without him knowing what the answer is. And so what that's going to do is it is going to be what is called a double-blind study. You hear about these a lot today in things like drug trials and things like that, where people researcher doesn't know, is the patient getting a placebo or are they getting the real drug, because we want to try and cut off what is called the observer expectancy effect. You see, when Pfungst held up those cards but he didn't know the answer, Hans went from getting the right answer right 89% of the time to just 6% of the time, which is a much closer percentage to those freshmen we were talking about earlier. And so it turns out that even though he wasn't intentionally giving away the answers, both Pfungst and von Osten were giving body language cues to Hans. Maybe it was a breathing out, a relaxing of the shoulders. And so we figure out that Hans isn't smart in math, but he's excellent at reading people. And so he could tell when he had gotten to the right answer, and so he stopped stomping, making it look like he could perform math. And so that is something called the observer expectancy effect. Basically, that when somebody is looking for something, they will kind of unintentionally go out of their way to actually see it. And so since they were expecting the horse to get the math problem right, there's a natural relaxation when he gets to the correct answer. And the same thing could happen anywhere, right? That's why double-blind studies are important. Double-blind studies are the idea that the researcher doesn't know what's being tested and neither does the patient or subject. That way, neither one of them can have their expectations interfering with the actual experiment. Say I had spent a lot of time coming up with a brand new drug to cure cancer. Well, obviously I've invested a lot of time and money into this. I've got a lot reputation-wise riding on this. And so even if I'm a really honest person, I might unintentionally do some things to make things come out the way that I want. And so the idea is you really want to trust the scientific process there. And so if I don't know, if I divide my subjects into two groups, I got a control group getting a placebo, I got an experimental group getting the actual drug, and if I don't know who is getting what, then I'm going to treat all of those patients the same. And so the only thing that's going to be different in the experiment is which one actually got the real medication. And so that's an important concept for us to learn about, and thankfully we've got Hans to help us out.